So hello and welcome to another video in a geometry basics series. And today we are going to be looking at the topic of polygons. And in polygons, there is one particular concept that often confuses a lot of students, which is classification of polygons based on the shape. Now, see, based on the shape, actually polygons can be of two types: convex polygons and concave polygons. Now, I think all of us should be very aware of what these two types of shapes are because all of us have studied optics in our high school physics. And in optics, we have looked at and we have learned about convex lenses and concave lenses, which is what I placed on the screen in front of you. This is how a convex lens looks. This is how a concave lens looks. So convex lens is a lens which bulges away outward from its center, right? When the shape of the lens is such that it has got a bulge away from its center, then it's convex. And when the lens caves inwards towards its center, then it is concave. That's why it has the word cave in it. It is caving inward towards its center. Same thing is true when it comes to polygons as well. Polygons which bulge outward away from its center is called a convex polygon. Polygons which cave inward towards their own centers are said to be concave polygons. Now, after having said this, I oftentimes give student an example of a polygon. By the way, polygon, as you must be knowing, is any geometric area that encloses an area using straight lines. So I give them the example of this polygon. And I ask them that, do you think this is a convex polygon or do you think this is a concave polygon? Most of the times, a very common answer that I get from students is that this is both. This is both convex and concave. Now, polygon cannot be both. I'm telling you right now that it cannot be both convex and concave. Every polygon is either convex or concave. When I tell my students this, immediately the class gets divided into 50-50 opinion split. There's a fight. Some people say it's convex, some people say it's concave. And why is there this confusion? Because there is one vertex which is clearly bulging away from its center, one vertex which is clearly caving in towards its center. And I can understand the confusion initially, but I feel that if you think very logically, there's a very proper practical reason to classify this particular polygon as one among convex or concave. And I'll tell you the correct answer, then I'll explain why. The answer is that this polygon is 100% a concave polygon. This is definitely not a convex polygon. This is a concave polygon. Now, what's the logical reason behind it? Even though there's one vertex bulging outward, why am I calling it concave? Because I give this challenge to everyone in my classes as well. And I'll give you the same challenge right now in this video. That try to draw a polygon in which all the vertices are caving inward. Or I try to imagine a polygon in which all the vertices are caving inward. And I'm telling you it's impossible to do because as soon as I draw one vertex caving inward, immediately the next two vertices, the adjacent two vertices have to bulge outward. It's not possible for all of the vertices to cave inward. It is possible for all the vertices to bulge outward. But all the vertices caving inward is impossible. And that is why we cannot define concave polygon as a polygon in which all the vertices are caving inward. Rather, the definition of a concave polygon is that even if one single vertex caves inward, it will be concave. And that is why this polygon is a concave polygon. Only when all the vertices are bulging outward will it be a convex polygon. Even if one single vertex caves inward, it's a concave polygon. Now, how do we decide whether a vertex is caving inward or not? For that, we need to observe the interior angle of that vertex which is caving inward. For example, in this figure, the interior angle of the concave vertex is this. Now, what can I say about the value, the magnitude of this angle? I think everyone can agree that this angle will definitely be greater than 180 degrees. And that is the numerical representation, a numerical definition of a quantitative definition of what a concave polygon is. Even if one single vertex caves inward, it is a concave polygon. Only when all the vertices bulge outward is it a convex polygon, or I can say that even if one single interior angle is greater than 180, it is concave. Only when all angles are less than 180 is it a convex polygon. So quantitative definition of convex polygon is that all interior angles have to be less than 180. Even if one single interior angle is greater than 180, it will be a concave polygon. Thank you.